Okay, so today we're going to talk about transformations of functions. In Algebra 2, you learned all about the transformations. This is going to be slightly different, just like everything we've done in AP Pre-Calculus. Like it feels familiar, but it also feels new at the same time. Same thing. These questions will never, ever be on the free response part of the test, but will 100% be on the multiple choice. And so I'm going to word it like they will word it on the multiple choice, but it is not something that you have to worry about memorizing exactly how to word it. You just need to find the correct wording on the multiple choice test. But we're going to practice it perfectly, but just know it's not one of those things that you have to, study or make up some acronym to remember the exact wording. All right, so on this first transformation, we're adding K on the outside of F. How is that going to change F? It's going to shift it up. That's what you learned in Algebra 2. We're going to call that, since it's up, that's going to be a vertical translation of the graph of F by, bless you, K units. So if K is positive, you just use that positive number. If K is negative, then you say by -2 units or -7 units. That's how it's worded in AP Pre-Cal. All right, what about adding on the inside? It moves it left to right, so it's going to be a horizontal translation. Good job. Of the graph of F by, what do you guys remember about on the inside? It's the opposite. So it's going to be by -h units. Now, when I taught Algebra 2, and even in my regular pre-calculus class, I tell my students that the inside lies. And so it's going to be the opposite or the inverse of what it's telling you because it's lying to you. But the outside doesn't lie. It does what it says. All right. And then what about multiplying on the outside? Well, the negative flips it. We are going to say that. But if it's a positive that you're multiplying by, that was going to be a stretch or compression. But we are going to call it dilation. So if it's on the outside, is that going to dilate it vertically, make it taller or shorter? Or is it going to dilate it horizontally, make it wider, narrower, taller? So it's going to be a vertical dilation. Of the graph of F by a factor of, now I'm going to put the absolute value of A, because Kennedy already mentioned a negative, or kind of what a negative does. So when you're deciding on that vertical dilation, you don't use the negative. You only use the positive version of the number. So what if A is negative? That is another transformation. It's going to be a reflection. Is it going to reflect it over the X or the Y? X. Nice job. You guys are remembering a lot. Usually, I think that the Algebra 2 teachers do a really good job with transformations because almost everybody in my classes remembers it. Okay, so now we're multiplying on the inside. When it's on the inside, it's going to be a horizontal change. So this is going to be a horizontal dilation of the graph of F. By a factor of What do y'all think? It's going to be another absolute value. Because I'm just going to tell you, it's not just going to be B. Just like when we did the horizontal translation, it wasn't just H. We have to do something to B. Any guesses on what we would do? What? Nope, but that's a good guess. Mm-mm. That's okay. It's going to be 1 over B. So H, this negative H, is actually the additive inverse. So the additive inverse is the opposite. 1 over B is the multiplicative inverse. So a reciprocal is a multiplicative inverse. So that's what you use. Use the inverse of that number. All right. Sometimes B is negative. And that's going to be a reflection over the y-axis. Right, and so I had a student like a long time. She's in her probably mid-30s right now, but I still remember the way that she remembered that the y-axis was the inside. She called it the yin side. So if that helps you get those two remembered, if the negative is on the inside, think of it like the yin side, and that's the y. Okay, so let's look at these examples. So what we're going to do is identify the transformations that map the graph of f to the graph of g. So this first one has two translations. Or sorry, I said that wrong. Two transformations. What are they? Yes, but we're going to write that the AP pre-cal way. It's going to take a lot more words, but it's okay. So it's going to be a horizontal translation of f by, are we going to use 3 or are we going to use negative 3? It's going to be positive. Very good. Because the inside's lying to you, you're going to do the inverse. So a minus 3 on the inside means 3 units. All right, and then what about that 2? Good job. And then when we're talking about dilations, we say by a factor. All right, do we just use 2 or do we do 1/2? 2. So it's on the outside, it's telling you the truth. If it's on the inside, it's lying. All right, now I am not sure if in Algebra 2 you did any that were as complex as this one, but you might have. But whenever there is a dilation and a translation inside, things can start to get kind of messy. Like right now, it looks like that is shifted, or there's a horizontal dilation by unit or by 6 units, but that's actually not true. And so what you need to do when that happens, and it doesn't happen that often, is you're going to need to factor out whatever the dilation is. Because that horizontal translation is also being dilated. And so it's not actually 6 units, it's actually 2, or negative 2, I should say. All right, so this one has 3. And we're just going to do them in any order. It's fine. So what do you guys think about one of the 3? What's one of the 3? Yes. So it's going to be a vertical translation of f by 5 units. So the outside tells the truth. All right, have a couple more. What do y'all think? This is good. Yeah, close. Very, very close. So it's going to be a horizontal translation of f by -2 units. Right, and then that 3, like, even though I have 2 sets of parentheses, these are the ones that determine inside and outside. So this is all inside. So that 3 is still inside, which makes it be a horizontal dilation. Of f by a factor of, what do y'all think? Not 3, 1/3. So my last class also, it took them a really long time to get that straight. So the horizontal stuff, it's never going to be the actual number. It's going to be the inverse. So if it's a adding, it's going to be the negative, or the opposite, I should say. If it's multiplying, it's going to be reciprocal. Okay, I'm going to do one more with you, and then I'm going to have you do one on your own. All right, so C has 2 also. What's that negative going to do in the front? Yes. All right, and then that -4 is also on the outside, so it's going to be a vertical translation of f by -4 units. All right, I want you guys to try D on your own, please. So D should have 2. 1/4 is 1, and the negative is another. Right, so that a -1/4 is going to make f like 4 times as wide as the original f and reflect it over the y-axis. All right, what questions do you guys have so far? Okay, so that's identifying the transformations. It's a little bit of a weird way. You're going to be fine. I'm not worried. The other thing we're going to do is apply the transformations. And this is something I'm not sure if you've done before, but I think you're going to be fine with this also. So we have this function f, and we actually have the algebraic form of it. And we are going to find new functions that take f and apply transformations. So h is the first one we're going to find. And it results from a vertical dilation of f by a factor of 4. So I know with a dilation, I'm going to multiply. Sometimes I multiply by the actual number, and sometimes I multiply by the reciprocal. And then sometimes it's outside, and sometimes it's inside. So what do you guys think for vertical dilation? Outside or inside? Outside. Do we multiply by 4, or do we multiply by 1/4? We multiply by 4. All right, so this is what I would do. That might be unnecessary work for you to write. You could just actually do that multiplication. And so we would take f and we would multiply every single term by 4. So that's a new function that is taking f and it is making it 4 times as tall. All right, so we also have m. That results from a horizontal translation of the graph of f by 4 units. Okay, so a translation where we're going to add or subtract, either inside or outside. So what do you guys think for horizontal? Horizontal is always inside. And do we add or do we subtract? If we want to have a positive 4 units, subtract. We do the opposite. Right? And then I feel like, I don't know for sure, I feel like what they would want you to do on the multiple choice is just actually set it up but not multiply it all out. I could be wrong, but to save time, we're just going to set it up. So f of x minus 4 means that you go to the function and everywhere there's a x, you change that to x minus 4. So instead of x squared, you have x minus 4 squared. Instead of negative 2 times x, you have negative 2 times x minus 4. And then you still have that plus 3. Now it's possible, yes sir?
So for the homework, do you want us to do both of them? Like,
You don't have to. It's possible that on the multiple choice test, on the real test, they will have this all multiplied out. I just don't want to practice that right now because I want to do something else. I want you to have a little bit more time. Yes. Okay, so you're going to do the reciprocal whenever it's a horizontal dilation. And so I don't think any of these examples have horizontal dilation, but this one did. Horizontal dilation, you do the reciprocal. All right, and then C, we have P of X. Oh, you guys do this one on your own. All right, this is a little different than part A. We distributed that for on part A. Here, you can't distribute addition, so you just add it to its like term, and that's the answer. All right, any questions so far? All right, the last thing we're going to do today is apply the transformations to a graph. This is my favorite part of the lesson. All right, so we need to remember some things from the front. So we are going to have it written in similar form to this, where we'll have stuff on the inside, we'll have stuff on the outside. So remember that the inside lies. So if it's happening on the inside, you're going to perform the inverse operation. To either the x-coordinate or the y-coordinate. So if you guys notice and remember from last year, stuff on the inside changes horizontally. So would I do this operation to the x or the y if I want to change horizontally?
Which?
The x. Right? And then for the outside, it doesn't lie. It tells you what to do. And so for outside, you're going to perform the exact operation. To the y-coordinate. Okay, so I'm going to show you what I do to get these set up right. There's probably going to be about 4 points that are like where the graph is like changing direction. So I would just kind of like figure out what those are, and then I would set up this table. And this first column is going to be the x-coordinate. The second one is going to be the y. And so for the x-coordinate, it's always what's happening on the inside. And so we have this x plus 1 on the inside. We're going to perform the inverse operation to the x-coordinate. So what's the inverse operation to adding 1? Do what? Subtracting 1. Alright, so I'd set it up that way for my x. Alright, the y is what's happening on the outside, and you're going to do the exact thing. And so on the outside, we're multiplying by -2, which is going to be a reflection, but we actually don't have to think about that right now. So we're just going to multiply by -2. Right, and then when we're done, we'll have these new ordered pairs for our transformed function. Okay, so I'm going to start with this one. This is -3 for the x. So I'm going to take -3. I'm going to subtract 1 from it. What am I going to get?
2.
-4. All right, then I'm going to take the y-coordinate, which is 1, and I'm going to multiply it by -2. All right, and then you just kind of go through that for each of the 4 points. All right, so then I'm going to go to the next one. The x at the next one is -1. So I'm going to take -1, and I'm going to subtract 1 from it. All right, and then the y there looks like it's 3. So I'm going to take 3, and I'm going to multiply it by -2. All right, so just keep doing that for all the points. All right, and then what you're left with is a table of values that is new ordered pairs for the transformed function. So you would just need to go through and graph those. Right, and then I always like to, when I'm done, just make sure that the right transformations happened. And so this one should have been shifted to the left one, and it definitely was. And this would be a reflection on the x, so flipped upside down, and stretched by 2. So it should be made 2 times as tall as this original one, which it looks like it is to me. So I was going to check myself, because it's easy to like just get distracted for a second and just do some weird multiplication or addition or something. Okay, we're going to do one more together, and I'm going to have you guys try one on your own. Actually, let's do this bottom one together, because it's a little bit more difficult. And then we'll go back and you guys can do example 4 on your own. What makes this one more difficult is the order that you do the transformation in matters. All right, so this one has this -2 on the inside. So I know that inside we're going to do the inverse operation by adding 2 to the x. All right, the outside has 2. So we have to follow the order of operations. Which would you do first, multiply or subtract? You would multiply, and you do what it says to do. So we're going to multiply by 2. And then we're going to subtract 1. All right, and this is the exact same original graph. So it's the same ordered pairs. So I still have the -3. Multiply by 2. So that'd be 2 plus 1 is, hold on. Subtract 1. Okay, so this one should have shifted right 2 and down 1, and it should also have stretched is to be 2 times as tall as the original. All right, so you guys tried this one. I'm going to come around and just look at your little table to make sure you're multiplying by the right thing or whatever, because this one is slightly tricky. write this different way, then it's fine. So some people are saying that on the x you're going to multiply by 1/2, which is 100% right. That's how it would be worded. Well, not really. It would say dilation by a factor of 1/2. But a lot of people are also saying divide by 2, which is exactly right. That's the division is the inverse operation of multiplication. But dividing by 2 and multiplying by 1/2 do the exact same thing, so it doesn't matter. Right, so this one should have shifted down, which it did, down 3, and it should be half as wide as the original. The height is they're the same height, exactly the same height, but it's narrower than the original. All right, so what questions do you guys have?